These are the examples for Algebra 2B, Credit 2, Lesson 16.1. Lesson 16.1, we're going to be learning about properties of logarithms. Properties is just a fancy way of saying what are the rules we have to follow when working with logarithms. So our directions for both problems 1 and 2 are to write as a single logarithm. Remember that terms are separated by addition and subtraction. So we have 1, 2 logarithms here. And again, our goal is to write it as a single logarithm. So the first property that comes into play is that we can take these coefficients, the 4 and the 7, and write those as exponents on the x and the y. So we have log base 5 of x to the 4th plus log base 5 of y to the 7th power. All right, so we still have 2 logarithms here, and our second and final step is to write it as a single logarithm. And we can only do that if the bases are the same, which they are. They're both base 5 logs. So our final answer is we have log base 5. Now, when the logarithms are being added, we can bring them together as a single logarithm using multiplication. So we have x to the 4th times y to the 7th. So our final answer is log base 5 of x to the 4th times y to the 7th. And that is it for the first example. All right, now again, as we always say, this is some new topics here. Or these are some new topics here, I should say. So again, pause, rewind the video to make sure you have a good understanding of what's being done. So our second example, there are some similarities, but there is one important difference from the first example. So let's look at an example for problem number 2. Problem number 2, we have 8 times log base 4 of x, minus 8 log base 4 of y. Our first step, just like we did with example 1, is to take those coefficients and write those as exponents. So we have log base 4 of x to the 8th minus log base 4 of y to the 8th. And so we've taken those coefficients and written them as the exponents. Excuse me. So now, our second and final step, notice here, instead of addition, we have subtraction. So recall with addition, we write as a single logarithm by multiplying those terms. When it's subtraction, we write as a single logarithm by dividing those terms. So we have x to the 8th divided by, remember fraction bar indicates division, divided by y to the 8th. And so our final answer, log base 4 of x to the 8th divided by y to the 8th power. All right, so that's it for our examples for 1 and 2. Again, maybe pause, kind of study the video there, or study the problem so that you have a good understanding. All right, so now taking a look at example 3, our example for problem number 3, we're going the opposite way that what we did with problems 1 and 2 is in that we are giving a single logarithm and we're asked to expand it, to write it as, there's 2 terms here. So in this case, 2 different logarithms. So we're basically doing what we did in 1 and 2, but in reverse. All right, so our first step is we have multiplication, x to the 30th times y to the 10th. So we're going to start by separating these into separate logarithms using addition. So we have log base 7 of x to the 30th plus log base 7 of y to the 10th. So notice we have the same base and then just log base 7 of x to the 30th plus log base 7 of y to the 10th. Our second and final step is to take these numbers that are in the exponent and bring them down in front as coefficients. So we end up with 30 times log base 7 of x plus 10 times log base 7 of y. So just taking the 30 and the 10 and putting them as coefficients. And believe it or not, that is it. So our final answer, 30 log base 7 of x plus 10 log base 7 of y. So just going over that again for the reading of it, which at first when you hear this, it almost sounds like you're poor grammar, you're not saying it correctly, and you are, but it's just getting used to the way we word things. All right, so let's take a look at an example for problem number 4, our final example. We have log base 5 of x to the 10th times y to the 8th over x to the 17th times z. Let's make that look a little bit nicer. All right. So now this one here, what you might be thinking already is that, well, we have a single logarithm. We're going to expand it, same instructions. If we had multiplication and we used addition, with division, we're going to be using subtraction. And yes, that's true, and that's the case, but notice we have 3 different variables up here. In fact, one of them appears twice. So before we even start expanding the logarithm, we have some simplification that we can do to make what's inside the parentheses, what we're taking the logarithm of, to make it more concise. So any variable that appears more than once, we can simplify that. So notice there's only one z, there's one y, but there's 2 x's. And in order to simplify that, remember your rules for exponents. When you're dividing, you subtract. And so let's go ahead and do that. So we have log base 5. Now for the x's, we have 17 minus 10, which is 7. But notice the larger exponent, the 17, let's go ahead and circle these. 17 minus 10 is 7. The larger exponent's in the denominator, so that's where we're going to write x to the 7th. So in other words, if this had been reversed, if the 17 was here and the 10 was here, we'd still subtract, we'd still get x to the 7th, we would just be writing our answer in the numerator. But as it is, the larger exponent is in the denominator, so that's where our simplified answer goes. Now with the y and the z, they only appear once, so we're just copying those down, and now we're ready to expand the logarithm. So we have log base 5 of y to the 8th minus, now we have to be careful how we do this. We have 2 terms, 2 logarithms, therefore, in the denominator. And that minus has to get distributed to all of it. So we're going to put this in parentheses. If we only had one variable down here, the parentheses wouldn't be necessary. But you'll see why in a minute that we need to do that when we have more than one term. So we have log base 5 of x to the 7th. And now that's being multiplied by z. So within the denominator, we have multiplication. So we're going to be adding these 2 logarithms together. So log base 5 of x to the 7th plus log base 5 of z, or z to the 1st, which is z. Now, so that's the expansion. Again, you might want to pause the video, rewind it to study it, make sure you got a good understanding of it. So now what we're going to do is, before we deal with the exponents, we're going to distribute that negative. Remember, that's like a -1 there to both terms in the parentheses. And that's why we had to have the parentheses, because that negative gets distributed to both logarithms. And we indicated that with parentheses. So our log base 5 of y to the 8th, we just copy that down. So -1 times log base 5 of x to the 7th gives us a negative log base 5 of x to the 7th. Same thing here, a negative times a positive is a negative, so negative log base 5 of z. Right now, our final step is to take the exponents where they occur, just like we did over here, and write them, bring them down in front, write them as coefficients. So we have 8 log base 5 of y minus 7 log base 5 of x. Now, there's only, I was going to say there's no exponent. There's always an exponent, but it's a 1. And -1, if it's a 1, we don't need to write it. So we have minus log base 5 of z. And so our final answer, we'll read it again, 8 log base 5 of y minus 7 log base 5 of x minus log base 5 of z. And that is it. All right. So that is our example for problem number 4. And that's it for the examples for lesson 16.1. So good luck with the work. Rewatch as needed. Rewind, pause, as we always say. Just stepping out for a second in case you wanted to pause the video to look at the examples. But that's it. So good luck with the work. And until the next video, take care and God bless.